Welcome back, Chapter 8. We're going to talk about confidence intervals. So, in Chapter 8 in the textbook, it covers confidence intervals for means and proportions. So, these are going to be lumped together. They weren't necessarily that way when I taught them this year. So, general form for all confidence intervals is just your point estimate plus or minus your margin of error. So, according to your formula sheet, that's going to be your statistic plus or minus your critical value times the standard error of the statistic. So confidence interval, you have some parameter and you take a random sample, you get a confidence interval. Another random sample, you get a different confidence interval, and so on and so forth. This would be how you're constructing these confidence intervals. If you're asked to interpret the interval, we're talking about one interval. So we're 95% confident that the interval from blank to blank captures the true mean of the population or true proportion, whatever you're dealing with. Confidence level, if we repeat the random sampling many times, it's your capture rate. It's this picture. About 95% of these confidence intervals are going to capture the true mean or the true proportion of the population. So you're always going to have to interpret an interval when you construct one. Confidence level, you're only going to have to do if they explicitly ask. They might say, explain 90% confidence, same deal. That's your capture rate. So just a reminder, why are we using the t-distribution? We don't know the population standard deviation. We estimate it with the sample standard deviation. That creates extra variability. That's why we use the t-distribution. T-distributions, they're more variable. Their degrees of freedom are n minus 1. But we also know as the degrees of freedom increase, the shape of the t-distribution gets closer to a normal distribution shape. So on this page, what I would suggest doing, honestly, if you really want to test yourself, is work through example 1 and example 2 on your own, and then come back to the video when you're done and watch me kind of work through it. One's a proportion, one's a mean. So for example 1, we're trying to estimate the mean height. I see inches. This is quantitative. So if you have a quantitative variable, you're using the t-distribution. And mean, we have one mean. So I'm looking at my formula sheet. Here are the parameters for one mean, mu. So that's how I know to use mu. It's the true mean height of the population. CVS, checking the random sample. It's a random sample of 40. 40 is less than 10% of all people. The central limit theorem applies. Conditions met. We're going to do a one sample t interval. Degrees of freedom are 39. Sample size minus 1. For the do step, they gave you the summary statistics, your sample mean, your sample standard deviation. You needed to figure out the critical value. So there's your statistic, your sample mean. There's your standard error of the statistic, sample standard deviation divided by the square root of the sample size. It's all there for you. And then you're just plugging that in the calculator to figure that out. And then the conclusion, we're 90% confident that the interval from blank to blank inches will capture the true mean height of the population. That's that. Number 2, now you're trying to estimate the true proportion. They either classify as Democrats or they don't. This is a categorical variable, so we're using the normal distribution. There's one proportion or one population, so my parameter is p, and my statistic is p hat. So I'm looking for the true proportion of US population that's going to classify as Democrats. So CVS, random sample of 500. 500 is less than 10% of all US adults. And large counts. I had 220 successes, so there's 280 failures. Conditions met, we're going to do a one proportion z interval. There is no degrees of freedom for the normal distribution. So anything with z, there's no degrees of freedom. The do step, I found my sample proportion to be this 44%, plus or minus my critical value, so I'm doing inverse norm, times the standard error. And that formula is right from the formula sheet. So we're 95% confident that the interval from blank to blank captures the true proportion of the population that classify as Democrats. So the last skill of this is finding a sample size. So what you're doing is you're taking the margin of error formula, which is just the critical value times the standard error, and substituting in and solving for the sample size. So the margin of error, 3%. The critical value was 1.96. If you don't have a prior estimate for this 0.5, I'm sorry, for the sample proportion, you're going to use 50%. That's the most conservative we can be. And then you just have to do the math to get from here to here. In this one, you get 1,067 point blah, blah. So you need to sample at least that many people. So you're always going to be rounding this up to the next whole number. So in this case, 1,068. I hope this video was helpful, just kind of rehashing a one proportion Z interval and a one sample Z interval.